I'd like to welcome everyone and thank you all for joining us today. I know some folks are just kind of trickling in. I also know that there's some heavy winds coming out in California, so some of our panelists may be experiencing difficulties. But overall, I think everyone can agree that 2020 has been an interesting year, and 2021 is shaping up to be similar, but if not better. But overall, I'd like to invite everyone to our second Digital Manufacturing Investor Day. Appreciate the time and effort that folks have taken not only to throw this event, but to actually attend and participate. So what is DMID and why do we throw it? So as many may know, Dendrite is a manufacturer of software in the space, but it is our goal to essentially elevate this industry across the board. And in that goal, last year we were approached by a number of fellow CEOs asking for help fundraising and help navigating the pandemic. And out of that was born essentially the first DMID, a way to help this industry as a whole by injecting more capital into the market, as well as providing critiques and advice to fellow CEOs. So as a result of it, as a result of the first one, which was very successful, we decided to do an encore. I'd like to take a moment to thank HP for sponsoring this one. They are the ones who requested this encore because they've also identified a number of companies who would benefit. And I'd also like to take a moment to thank Develop 3D and 3DM as essentially our marketing and media sponsors. So with that, I'll focus directly on the companies and we'll get straight to the panel. So we announced the companies yesterday, and I want to take a moment to acknowledge just sort of the diversity of the companies here. Not all of them are software, not all of them are hardware. Some of them are even producing materials. And I think it's important to recognize that this ecosystem takes all kinds, all working together in harmony to achieve a greater, broader purpose in manufacturing. So I'm pleased to announce that these are the 8 companies that were chosen for this event, and I'm very excited to show you what they're gonna talk about just momentarily. So with that, I would like to begin introducing our panelists as they're coming in one by one. I'll just give them a quick brief introduction. So the first panelist I'd like to bring on is Arno Held. He is the Chief Venture Officer at AM Ventures, a sister organization to EOS, arguably one of the leading manufacturers in the space based out of Germany. Thank you, Arno. I'd then like to bring on Ron Fritz. Ron has spent over 24 years in this industry, and the software that his company makes, TechSoft 3D, is the backbone of numerous pieces of software in this industry, and he provides a unique perspective as a CEO. I'd like to also invite on Heidi Roizen, who is a partner at Threshold Ventures. Most people should know who Heidi is because she has a pretty historic and storied career. Thank you, Heidi, for joining us. I'd like to invite Avinash Rugoobur. He is the Chief Strategy Officer of Arrival, which is in the process of actually going public right now. Thank you, Avinash, for taking the time for attending our event. I'm sure you're pretty darn busy at the moment. I'd like to invite a personal friend and mentor, Amar Hanspal. He is the CEO and co-founder of Bright Machines, and previously was the Chief Product Officer and co-CEO of Autodesk. And then finally, not least, I'd like to invite James Taylor, who has also a pretty long and storied career, but is currently residing at HP Tech Ventures and is the main sponsor of the event. James, do you want to say a few words?
Oh yeah, just thank you all for joining us. We had measurable impact from the first event that Harshal mentioned, but it's really important that we understand that there's a significant downturn in startups, early stage startups' ability to raise capital. And that's why we're holding this, right? And so it really is a great example of 2 companies working together, a dynamic, fast moving company like Dendrite working with industry stalwart like HP to create mutual success in the market is really why we hold these, right? So once again, welcome to the event and look forward to working with you.
All right, so to sort of kick things off, Amar, we were talking the other day and you had a few, I think, very strong, but very direct and blunt insights. Why don't you kick things off by maybe describing some of them? And I'm sure we're going to have a pretty fun and interesting conversation across the board.
Yeah, Harshal, thanks for having me. Good to see everybody. I think the other day I'd had a little too much coffee, and I was chatting with Harshal, and we were talking about sort of, the big changes that are happening in manufacturing. And I strongly believe, we're in the first innings of a long secular trend in the world of manufacturing. And I would describe it in like 3 or 4 dimensions. One is computer aided design, which has really been computer assisted design, is shifting from sort of that paradigm to computer generated design, where the computer is an active participant in solving the product development, product engineering problem, as opposed to just recording, which is what it has been so far. It's been a recording device as opposed to an active participant. Going from semi-automated, mostly analog manufacturing facilities to fully automated digital manufacturing, which is really a transformation of the factory floor, along with a, really the prevailing manufacturing model has been what I call N equals thousands or millions, which is, sort of the industrial era of making lots of something, to moving to more like N equals 1, where you could make highly custom products designed for a particular function, as opposed to being optimized for, industrial means of manufacturing. So analog to digital, N equals thousands to N equals 1, and then from sort of making things in large centralized facilities halfway around the world to a more distributed manufacturing infrastructure closer to the customer. So, I think manufacturing is definitely shifting in these 4 or 5 dimensions. And the question is not if, the question is just when. I think the real argument that we all have is, how quickly is this shift happening? I think there's no doubt that the shift is happening. And the real debate is just, will it take 5 years, 15 years, 50 years to make this shift? And I think many of us come out on different angles of this, different, points on the spectrum. But that's what, Harshal and I were talking about the other day.
Well, I agree, Amar. On that note, right? Of course, I think 5 years is actually not a long time. And I think if you ask some people, they might even say on the order of 6 months.
6 months. Yeah.
I'd say, Arno, do you have an opinion on the topic? Coming from AM Ventures and you, are you seeing similar trends in the space? Or Heidi, do you have a comment?
Arno, go ahead.
I'd say Heidi, why don't you go ahead?
From our perspective, I think it's often said that things feel like they take longer, but then actually they kind of mushroom and the impact is far greater. And I think that not only are we seeing changes all along digital manufacturing in terms of the processes, the parts, the components, the visual inspection, AI applied to visual inspection. We're seeing all sorts of elements to each piece that together creates a rather massive change. And then beyond that, we're even seeing change in the opportunity of what is manufactured. I would use 2 examples that I've been involved with, both in autonomous vehicles as well as in cell-based meat, where you're actually changing a whole industry because you're changing the product itself, right? In the case of autonomous vehicles, you're changing from a product that's intended for sale to a product that's probably, for many, will replace the ownership of the vehicle. So it also changes the whole business model of what's being manufactured in the first place. In cell-based meat, of course, you're moving from an agricultural-based product to a product that is a factory-based product that can be much closer to the places of consumption and has all sorts of different, both pros and cons to it. And so you're, in essence, creating design elements and creating processes that have never existed for the status quo of what was being manufactured to meet consumer need in the past.
Cool. Yeah, I'm just, this is a great point. I love the little translate what Amar picked up on, which is really how you mentioned how we manufacture and what we're manufacturing. But one thing I'd love to hear is Avinash's rivals' take on, the microfactory, right? The fact that they're looking at building their electronic vehicles locally rather than in large centralized factories. So drafting on that, I would love to, hear Avinash's points on how he's really fundamentally shifting manufacturing.
Yeah, so I think totally agree with what Amar and Heidi have both said here. And I think ultimately this is, the confluence of multiple technologies that have now enabled us to do at Arrival many of the things that have been discussed so far. So ultimately we're taking that traditional approach, which has been the production line approach, at least for vehicles, and we just questioned it. That's normally not something that gets questioned, actually. It's normally just a given, whether it's a new startup or an OEM making electric vehicles. They just assume that that's there, and they're trying to amortize that cost there for many years. So we questioned, why is it like that? And so we created a microfactory, which instead of a line-based approach, it has a automated cell. So each cell does a certain operation, and you have autonomous vehicles that move parts of different cells. And we've been able to shrink the factory to 1/10 of the size. We've been able to bring the CapEx down under 50 million, and we can basically put these things anywhere. So the idea is you take a warehouse and you bring this robotic and manufacturing system to it, and you convert it to a plant that can create electric vehicles, so hyper-local. But to enable that, interestingly enough, you actually then have to go look at how you design the product.
Yep.
So then this whole idea of, from the sketch to the engineering to the design to the engineering to manufacturing has to be in a whole, as a whole. You can't just assume that, hey, we're just going to go build it in a microfactory or build it this way, because the product design doesn't enable you to do that. So at Arrival, we had to go vertically integrated to achieve that. We had to question everything. Why use welding on a vehicle? What are other technologies you can use? Why do we use metal stamping? So we created a composite material that enables that. So everything's designed around the way you do the microfactory. What's going to come in the future, what this enables is, Amar mentioned, an AI to take everything's controlled. So you can actually look at the operating process and optimize it. And it doesn't need to be done in a, let's say, a human organized way like traditional manufacturing is done, where with a stopwatch, you're timing everything. You can because you're controlling everything, you can just let the AI run multiple simulations, and it almost becomes an organic manufacturing system rather than the typical production approach. So there really is a lot there. And then when you tie that data back into the product design, at some point, you can see that the computer is predicting designs that are going to be more readily manufactured and really create the whole loop. And I think that's where the technology will go over time. But decentralizing that manufacturing requires a lot of other technologies that I think we're only now able to put together to enable.
So I'd say, Avinash, it's clear that software is going to play a major and important role in this process, right? Because what you're essentially saying is that all of these different robots and technologies, right? The key is how they're controlled and and how they're used, right? Whether it be cars in your case, or for example, the meat products that Heidi was just talking about, right? Clearly software is kind of a key defining characteristic of this change. I'd say, Ron, as someone who has quite a bit of experience in the software space and has been, making strides and marching forward in the manufacturing space, how are you seeing software's role change in this industry? Do you have any comments on this?
Yeah, that's thanks, Harshal. Our experience comes from providing core technologies that lots of companies use when they're making manufacturing software. So my information about what's changing in manufacturing is secondhand, filtered through that, but aggregated between what we see from all these different people developing software, sometimes pure software developers, sometimes hardware developers making applications. In the case of additive, one of the big things we've seen is, this puzzling for many years of why hasn't this been adopted, and there's lots of thoughts about why, but what we're seeing now, and I think the panel, the folks who will be talking later will show, is that there were all manner of pieces of friction in the process, from getting data getting data that's rich enough out of the CAD system, preparing that to be printed, the materials that need to be used, the intelligence of the machines, and people are really working on each part of that friction in the process. So as Amar mentioned, it's sort of we're out of the gate now, and now it's just a matter of when this will get adopted. It's not a matter of people scratching their heads and saying why there's so much value in 3D printing. Why isn't it? It was all these friction pieces. We definitely see that there's a trend toward this, what Amar referred to as n equals 1, and this knowledge that things are going to be done in small batches. That's going to have big impacts on where manufacturing is done, and the calculus one uses to say where should we develop this. If you don't need a massive factory like Avinash was describing, the math changes pretty radically. And the final thing we're seeing is the companies we tend to work with are kind of at the front end of really removing this friction and just slightly one step into the future. But I've actually run across a lot of companies in the last year or so as we look at M&A activity that are actually working at the very beginning, like earlier it was referred to as, smart factories or semi-automated factories. There's a lot of factories that are almost not automated at all. And I think that if I were an investor, I would also be looking at the front end, but also the large back end of the market where you have factories that don't have any information, and even any sort of IoT capacity takes them a leap forward. I would view it as analogous to like Southwest Airlines was a great investment, moving people from driving to flying. And there's a lot of that in the factory as well. Like the people in this group will always tend to be looking at what's pushing it, but there's a big laggard market here too.
Yeah, very cool. Yeah.
I think one of the interesting things you just said though, Ron, is if you look at the other end of the spear, the tip of the spear, the manufacturing process is actually part of the competitive advantage or the business model of the company, right? It isn't just the afterthought of how you make the thing once you invent it. It's, moving things, for example, closer to the customer and having micro factories is part of what makes the business model
competitive advantage,
for sure. More important.
For sure.
So I'd say, Ron, you brought up a good point on the adoption side of things, right? Like, what are the key business issues that need to change, right? Arno, you've been in this space for quite some time, and you've seen its evolution, honestly, over the last 30 years. Do you have thoughts on this, or even trends on the companies that you're seeing that are driving this business innovation as opposed to necessarily technological innovation?
Oh yeah, absolutely. Just the fact that now suddenly we see a whole big range of application startups popping up, like engineering teams who know exactly how to use this manufacturing technology and to design for this technology to create parts that simply cannot be produced with any other kind of technology out there. It's electric motors are now being produced that are so much more compact and light and efficient than their conventional counterparts. The same goes for heat exchangers, for example, double-digit billion-dollar market. And there are a couple of startups out there actually disrupting this field because they exactly know how this technology works and how to design for this technology and generate revolutionary products. And until a couple of years ago, we did not see these startups. I started in this industry 13 years ago, and everyone was waiting for the point, when does it finally happen? And over time, we built really nice technology, great materials, portfolios, etc. But everyone was asking for these applications, because in the end, applications are the justification for the rest of our work. Only if we have mass applications, we see that this technology is ready to be a viable manufacturing technology. And in my opinion now, this is exactly happening right now. The past 9 months have been really, really impressive in terms of dynamic and application startups popping up. And I expect many more to come in the next couple of quarters, I would say. So that is certainly a very interesting development that everyone has been waiting for.
So so it seems like the overall panel is agreeing that there is a movement towards taking AM from kind of a prototyping phase to kind of a production phase, right? And then there's also this sense of, the future is essentially personalized and industrialized, right? So when Amar says n equals 1, right, he's talking about going from a production process that would be considered low mix and high volume to a process that's extremely high mix and high volume, so that you can potentially do these, personalized, products and customize things for very specific and hyper-tailored applications. I mean, I think it's no surprise that a lot of the companies that are going to be presenting today actually fit in in those themes. Right. By the way, to anyone who's watching, this was not planned or anything. This is just sort of the nature of this industry. I'd say for a number of the venture investors who are sitting here and watching, trying to learn about this industry, I'd say, Heidi, do you have any advice on, what to look for, what things that you're concerned about, what things they should be really looking for? Because I have also this general sense of just being in the space that there's not too much education about the companies in the space and how to evaluate them compared to like your traditional Silicon Valley software startup. Do you have any opinions?
Yeah, I mean, particularly because compared to traditional software companies, the problem is, CapEx, right? And the fact that these companies are often much more expensive to get off the ground. And I'm going to give you very dumb, basic advice, but it's worked well for us, which is you just have to stay close to the customer. I think that one of the fallacies of being in venture is that you're a genius about this stuff and you see a change in technology and you'll think it's amazing. And then what you discover is that there are things about the process that the customer could have told you in 5 minutes that as whizzy as the thing is, it doesn't survive the interaction with the customer. So we tend to be even more customer centric in our evaluation of manufacturing related technologies. And even for very early stage companies, we probably aren't gonna, now we are a Series A investor, so we don't typically do the seed investing on a PowerPoint and a laptop. But we are looking for customer validation from a very early phase. And I think the most successful companies are working hand in hand with a small set of customers that they choose to be there from the very beginning so that they're getting that validation as they go along. Because of course, it is very hard to pivot these kind of companies. You really have to kind of be on the right track from the beginning.
Yeah, I agree. I mean, I'd say, James, I think you also have thoughts on this, right? Because I mean, you weren't traditionally in the manufacturing space and then you sort of did a pivot, right? I mean, for all the folks who are concerned or worried about market size or what, this space entails, maybe can you give your insights and thoughts?
Yeah, actually, Avinash had a lot to do with this, actually. We were actually at a Warriors game. I was sitting with Avinash and Allison Malik. They were working at General Motors, and they were actually the pivotal people on the Cruise acquisition. And I had been known as a frontier tech investor, really focused on transformative industries, right? And I hadn't seen enough of this happening in additive manufacturing. A lot of incremental great technologies happening, but nothing transformative. And that unpacking the acquisition of Cruise by General Motors really enlightened me to a new thesis of that we're fundamentally going to change how we build an electric vehicle and autonomous vehicles. And I started really attacking investment opportunities in those manufacturing spaces, right? And so that has been very, very lucrative. That was a seminal moment in the industry driving the transformation of automotive manufacturing. They haven't seen this much disruption in 100 years. Right. And so it really enlightened digital manufacturing because we're totally shifting how we build things. So we mentioned everything from automobiles to how we actually build rockets for space exploration to food production. All of this is dramatically changing and is through the digital process. So that's why we're behind it. That's why I've shifted my investment focus. And that's why I actually kind of rejoined with HP to kind of build this future out.
All right, so then maybe kind of shifting gears from a topic standpoint. I mean, we've seen that overall in the industry, just from kind of experience, that at least, for example, as additive manufacturing is concerned, it has honestly just had a higher adoption rate in Europe compared to the United States, right? And there's been obviously a major discrepancy. One of the obvious reasons would be probably just due to where some of the hardware OEM companies are based. But, it's kind of odd that this major discrepancy still exists, in this day and age. Say, Arno, coming from that side of the world, right? I mean, do you have thoughts or ideas, and why is the US sort of behind compared to, I'd say, for example, like a leading German automotive manufacturer?
Well, it's an interesting question. We have also tried to look at this in quite detail. Our database consists of about 1,600 startups in additive manufacturing that we've collected for the past 5-6 years since we founded AM Ventures. And we also compared the survival rates and across the different regions of the world and the different industries and technological categories, whether it's software, hardware companies. And for me, the only logic explanation simply was that we do have a very strong ecosystem of hardware technological companies in, let's say, the southern part of Germany, in Austria and Switzerland. So anything, the axis between Stuttgart and Vienna in Austria is quite an industrial powerhouse in Europe. And this is also where major parts of 3D printing were, let's say, first commercialized, not necessarily invented, but first commercialized and also firstly used. And it's a very engineering heavy region. So the engineers first dealt with this kind of technologies from very early on. And when you look at what are the first were the first applications that were developed for additive manufacturing, it's mostly aerospace and medical. And both are industries that are very strongly represented here in this part of Europe, or especially Germany. Whereas the United States is much stronger on the software side. Of course, Silicon Valley is one of the 3 hotspots that we see in the US for additive manufacturing, next to Boston and Austin. But for software, it simply took much longer. Everything started with laser and scanning technologies and hardware, and then moved on to the materials disciplines. And software was, let's say, the third step of industrial 3D printing development. And then very strong technical education of students in German, Austrian and Swiss technical universities who were among the first ones to adopt 3D printing in their curricula, also helped quite a bit. And this is why we see the first strong applications actually developing in Western Europe, and software is very strong in the United States.
It seems like, kind of core to the central thesis of your answer was that it's almost like it's a sourcing problem, right? It's a talent sourcing problem, because this is a new industry and not many people necessarily have experience, in the technologies or know much about the technologies. So forget even necessarily running the machines, right? I believe that there's also a sourcing problem in the United States for even finding people who know how to run these machines, right? Which is why computing and software and automation is going to be really important. It's not necessarily taking jobs, it's because no one is necessarily even applying for these jobs because they lack the training. It's Amar, right? I mean, you're sort of kind of tangential to that space. Do you agree with that? I mean, how do you see the job evolution kind of here?
Yeah, I mean, I think there's no doubt that there is a displacement coming in terms of skill set required, right? I think you've seen this in other industries, and you can look at agriculture, or you can look at the world of retail as it morphs and it becomes more e-commerce oriented, right? Who's like you require different skills, and I think the same thing is going to happen in manufacturing. And I think what we are noticing with our customers is the more automated customers become, the more they emphasize what I would call the front office, which is customer service, collaboration on the engineering side. The skill set kind of moves towards the human skill set, moves towards that, and there are fewer people required to run the automated factory. I mean, this is, I think, the challenge I have when I always listen to bring back manufacturing jobs. Yes, manufacturing jobs should come back and will come back, but there will be fewer of them, and there will be more highly skilled. And the rest of what the enterprise needs is more front office. I just want to touch on one or two things that were discussed along the way. I mean, one other thing about Europe on the previous conversation you have to remember is that Europe is more environmentally conscious. So it pushes the automakers to start doing things like lightweighting and those kinds of things much earlier. And so you've seen those projects crop up. And that's only to suggest that, government can play, or external factors can play a role in accelerating technology adoption. And the other thing to also, I think, remember is that one pattern that we've seen in other industries is that what digital enables is the collapsing of the front and the back. And I think Heidi touched on this a little bit, but when you think about the most unsexy thing that has become sexy in the last 20 years has been logistics, like Uber and Amazon warehouses. Like, who cared about any of that stuff? But the fact that you require a digital back office to provide really good customer service, in some ways, these guys proved the inverse, is that in order to deliver good customer service, you need a really good back office. And I think the same thing's going to happen in manufacturing, which is that customers will want better service, and that will be the business reason, along with some government pressure, to drive digital transformation in manufacturing. And what's going to happen with jobs is that they're going to move from the factory to the front office. I can talk for this for hours, but let me just stop there. That's what's going to happen.
I want to just add on to that, because I think one of the things that happens when we digitize manufacturing, we are also decentralizing it. And when you're decentralizing it, you're bringing along an ecosystem, and the jobs move. You mentioned the front and the back office, but it also moves into different sectors to now support local products. So if you can imagine the typical amortization of a factory producing mass volumes, and you've just fundamentally changed the economics of that factory by putting it, down the street, for example, you're creating more local products, and they're going to need a different level of ecosystem around that, which is, again, movement of the jobs, maybe from the actual manufacturing process to supporting them, to product design, to other things around that, because you're no longer having this idea that somebody sits in the US or the UK or anywhere else and designs a product that works for everybody. You start to change that over time, which becomes, we can design a product that works for us locally, because again, we're changing the economics of this. And then there's an ecosystem that builds around it. For jobs, that's really important, because what in our conversations at Arrival, when we're talking about governments about bringing the microfactory over there, it's not necessarily just the manufacturing jobs. It's that ripple effect of what putting a local production does to the economy in the area that it's in. So I think that, these things go hand in hand. I think with the decentralization comes unique opportunities. And I think that also then starts to extend to being able to balance out some of the, let's say, some of the issues we've had in the past about where we place factories, how we place it, the sort of labors that we use for that, and evening out a lot of that across the world. I think that's also going to be a social benefit of the change in manufacturing.
So I hate to say this, but we've honestly actually just started to run out of time, and to stay timely and get to the startups, we'll have to kind of shift some gears. I mean, I think we can spend hours honestly talking about the subject. I mean, and we're only really starting to really dig in. I'd say before I make the transition, does anyone have any last 5-second thing they'd like to say before I formally thank you all for participating and helping out with this event? No, last 5 seconds. Okay, well, with that, I'll formally push aggressively the transition to the startups. I'd say thank you, James, Amar, Avinash, Heidi, Arno, and Ron for your time. It's always a pleasure talking to you, and I really do appreciate your time today. Thank you. So with that, we're going to shift gears and start introducing the startups. The first company I would like to introduce is Nanofabrica. I'd say I can't really summarize Nanofabrica in one sentence, but what I will say is I'll summarize it in a comment. You're going to first see the things that are made on their machine, and you're going to go, whoa. And then you're going to see the scale of what those things are, and then your mind's going to be blown. So with that setup, I'd like to introduce Nanofabrica.
Hi, I'm John, CEO and co-founder of Nanofabrica. We do ultra-high precision 3D printing. This brings 3D printing into new markets that require high precision. Markets like electronics, optics, semiconductors, medical devices. We're a startup that's based in Israel. We raised our seed round of $4 million.
So we're going to now move to the question and answer part of this session. Can the representative from Nanofabrica come on the camera? John?
Yeah, I'm trying to.
Okay. Well, while you're figuring that out, do any of the panelists have any questions of John? You guys get first dibs.
I'll start with a question. You talked about the cost advantage in terms of making the injection molds, but it sounds like you also actually make the parts. Many of the things you're going to be making the parts themselves, and I'm wondering if you could just talk about what the cost difference is. I know it's a very open-ended question, but
oh sure. So in general, we sort of running, I'm not sure if this is what you meant, but we're running a kind of a service center, demo center of printing parts for customers. And the whole aim of that is related to what you talked about, to be in contact with the customer from day one, which is what we've been doing. In terms of the parts themselves, so pricing of a part, of an injection molded part, you would calculate that by the number of parts divided by, you know, the price that it takes to set up, which basically is the mold. So there's a kind of a cutoff. It depends on the part. It could be around 10,000 parts. It could be even around 100,000 parts.
Okay.
Somewhere around that.
Great. Thank you.
Thank you.
Hey, John, Ron Fritz here from TechSoft 3D. So you mentioned starting with the injection mold. Why is that your beachhead? Is it seems like in terms of producing those, they seem like the simpler of the things that you're capable of producing.
Yeah, honestly, so the way we found sort of the applications and the killer apps and sort of our go-to-market was through interacting with customers from day one. And that's what we got a lot of pull on. A lot of customers suffer from, you know, people that are injection molding a lens, let's say, you know, for optical communications. It could take them half a year to get the first prototype, which is completely crazy in 2021. We can do that in a day. So we got a lot of requests from there. We saw with a design partner that we can get to a few hundred injection molded parts. As the parts get smaller and the molds get smaller, you need precision, and they also get more expensive. So it's a good fit to start off with.
Mm-hmm.
Hey, John. Arno Held, AIM Ventures. Thanks for the presentation. Good to see you again. Can you elaborate a little bit on your go-to-market and how much traction, how far you've come already?
Sure, I would like to use that opportunity to share a screen photo. Can you see it?
Yes.
So this was yesterday. This we didn't announce it anywhere, but this was our first shipping of a beta machine. So that's fresh. It just happened yesterday. I'm of course super stoked about it. Very excited. So the go-to-market is shipping of betas. We're aiming to ship the second one in a month, a paying customer. Both of those are in Israel. The third one's going to go to the US end of Q1 in about 2.5 months. The idea of going through that, I mean, we sell machines to whoever wants to buy them, but the company's doing the go-to-market through the applications. So we're navigating the go-to-market based on the killer apps, and that's our Northern Star. So the first one is short batch injection molding, and the second one is high precision positioning of optics. The third one is probably going to be already medical.
So I have a question coming in from the audience for you. I guess, what are the current limitations of the existing processes for direct, printing these lenses or these enclosures, and why is your process in particular important? And maybe also comment on the materials that you're printing.
So in general, with, let's say, not even printing, but existing technologies, as parts get more precise and smaller, at some point the price starts to go up. You start to have to pay more dollars for high precision CNC, high precision injection molding. There start to be less manufacturers that know how to do high precision injection molding, for electronics or semiconductors and so on. With 3D printing, as the part, or our technology at least, as the part gets smaller and more complex, you're not paying more for the complexity, so you're actually paying less as the part gets smaller. So that's our sweet spot, finding the killer apps of small, high precision, complex parts. And that's where it can really get to mass manufacturing and not only stay in prototyping or short batches.
Would you say that your machine is essentially being set up for a production grade run, or kind of what's your sweet spot? Is it initial prototyping? Is it full grade end use production, or just kind of across the spectrum?
So it's I would say it's a combination between Avinash's micro factories, if that's okay to use that. So like putting a machine in every one of Avinash's or the Amar's factories locations, that would be one use where you want to do a shorter batch, high mix batches. And the other one is the manufacturing side for Apple to make like behind me and that. So like the manufacturing of specific parts, the applications that Arno was talking about, that the industry is looking for these specific applications. That's where we're really going to win as an industry, I mean.
All right, so we have about 1 more minute. Do any of the panelists have any other questions for John?
If it's okay, I would like to say one more comment and
Go for it.
another question comes. So Heidi mentioned two issues in companies like ours: CapEx and stay close to customers. From day one, we've been on customers. Like before we had any technology, we were talking to customers. The other thing that I would like to just say to everyone is that this industrial high precision deep tech machine was shipped, and we've raised so far $7 million. We've used about 4 million out of that. So we managed to ship a machine to a paying customer with $4 million, which I think is a great achievement. I just wanted to share that.
I'd say it's a tremendous achievement because
Absolutely.
normally that number requires at least 1 or 2 more zeros attached to it. So that is a tremendous achievement, John. I appreciate it. Any other questions before we transition to the next company? Nope. Well, John, I appreciate your time. I appreciate your comments, and congrats on the picture from yesterday. I mean, that's freaking awesome. Thank you for sharing it with the audience today.
Thanks a lot. Bye-bye.
All right, so transitioning to the next company, we have Copprint. So Copprint's technology is also already kind of used in production. They make a copper ink. So they're one of the companies that we picked who sell essentially a material. The interesting part about Copprint is this copper ink can be not only used to make cheaper circuit boards, but greener circuit boards. So with that, I'd like to introduce Copprint.
Hi, my name is Ofer Shochet, and I'm the CEO and co-founder of Copprint. At Copprint, we make copper ink that are transforming the way people make circuit boards. It's relevant for a lot of markets, for photovoltaic cell, for RFID, and for general PCBs. We founded the company about 5 years ago. 2 experienced entrepreneurs, world experts in nanotechnology and 3D printing. We ran it 2 years in a garage mode and then raised funding from 2 industry giants, from Henkel and from HP. And very recently, Tatsuta from Japan joined in as an investor. Electronics is around us, everywhere, and the conductive element is really the basic building block. About 100 years ago, it was made by wires, and then in the 1920s, people started using also printed silver in order to make the circuit boards. Since the 1950s, people are mainly using a chemical etching process, which is a highly polluting process using toxic chemicals done today mainly in China and Malaysia. This is how we are doing PCBs today. Is it possible to make it cheaper? Is it possible to make it in a non-polluting way? Is it possible to make it in Europe or the US? The answer is yes. With Copprint, it's possible to change very much the PCB market and the printed electronic market. And this is the way that people are making today: connectors, display, RFIDs, sensors, and in 10 years from now, a major portion of this market will move into copper inks. So what do we sell? We just sell ink. See on the right-hand side, it looks like chocolate, just more shiny. The price is about $200 to $500 per kilogram, and we have a nice gross margin. We see a big need and customer, and we started selling about a year ago. For many years, people wanted to create copper inks because silver is very expensive and copper has the same conductivity level, just much cheaper. However, copper oxidation prevented the conductivity of the inks. At Copprint, we solved this problem. We patented it. We have a granted patent how to make copper conductive. And eventually, as you can see in the graph, the conductivity of our copper ink is higher than silver. We are also cheaper. So usually there is a 5 to 10 times better price performance for the copper ink relative to silver. Few examples for usage. The RFID market. This is actually the biggest by number PCB that is made. More than 20 billion units are made every year. And these are made today using aluminum and plastic. Yes, aluminum and plastic. Non-degradable, non-recyclable, non-collectible. Instead of that, it is possible to print copper on paper and obtain compostable RFID antenna. And the good news is that the compostable antenna using the Copprint technologies are cheaper than the aluminum and plastic antennas that are made today. We have partnership with the biggest RFID equipment vendor in the world, Mühlbauer from Germany, and recently signed an LOU with one of the biggest RFID vendors in the world to start deploying this technology in 2021. Another very interesting market for us is the market for consumer electronics and automotive. Actually, all the simple PCBs, one-sided, two-sided, which is about 30% of the total PCB market, will be cheaper to produce using printing than using chemical etching. And it's a huge market. And of course, the people that are working today on electronics with silver, switching to copper will make everything 5 to 10 times cheaper. Another very important market for us is the photovoltaic market. Photovoltaic cells are made today with silver inks, and just the cost of the silver today every year for this market is more than $2 billion. With Copprint technology, it is possible to cut the cost of production of the whole photovoltaic module by 15%. This translates to 15% cost reduction of electricity. We were founded 5 years ago. We raised first funding about 3 years ago from Henkel and HP. Since then, we scaled up our production by a factor of more than 2,000. We've proven our gross margins and started selling. We shipped, even though COVID year, we shipped our products to 25 countries to paying customers, and we are very happy with the progress. We recently raised additional funding from Tatsuta. I'd be glad to explain more about Copprint and to talk to you further. Thank you very much.
All right, we're going to shift to the Q&A section. I see Ofer is already on camera and can unmute himself. So do any of the panelists have any questions for Ofer?
Yeah, Ofer, on the photovoltaic, what testing have you done, or POCs, or who you're partnering with that side of?
Well, I cannot mention the name of partners. I can just say that the photovoltaic is doing heavy testing. We just finished more than 1,000 hours of testing of full modules in 85 degrees, 85% humidity to simulate 25 years of work. It's a very conservative market. I mean, actually, all the market that we are interacting with are manufacturing market. So a lot of testing is done. Just as an example, with the RFID market, we are actively working with companies for almost 4 years since almost we founded, in order to go through quite a lot of tests, and it all looks very promising.
Any expected time to finish, for example, the photovoltaic test, when you'll be done with at least the?
I believe that still 12 to 18 months for that. We already created, cells with very high efficiency and much lower cost than they are today. But this is a very conservative market, as you know, where people give their a commitment for 25 years of work. So I will not, let's say it almost doesn't appear in my business plan right now, although it's a huge opportunity, and I can also say from environmental perspective, a very important one.
Thank you.
Go for it, James.
Yeah, hey, good to see you again. What's your competitive advantage against the other copper solutions that are in the marketplace? We're starting to see some movement there. You obviously have a great head start. Is it use cases? What is that competitive advantage that you have?
So I would mention that people try to develop copper ink for more than or about 100 years. DuPont spent probably hundreds of many years trying to do that. And people released copper inks. If you search online, you will find it. But then you need to look on few issues. One is when you say the word conductive, what is conductive? I mean, also my table is conductive. I'm a physicist, so it's a very low conductivity, but it is conductive. So you need to measure how much is it conductive, and usually all the attempts that were made or are being made have at least an order of magnitude less conductivity than the Copprint ink. This is one issue. The other issue is what is your process? Do you need an inert environment, any gas, argon, nitrogen, etc., in order to go through the production, or can you do it in a very simple and cheap equipment? And this is a very big differentiation between us and the other attempts in the market.
I have a question as well. This is Ron from TechSoft 3D. So you mentioned, let's take the RFID case, and you can print copper ink on paper, much more environmentally friendly, much cheaper. What's the cost of switching for someone that has a current process set up for the way they manufacture these RFIDs now to be able to move to yours? And is that a barrier?
Okay,
How much of a barrier is it?
Yeah, most of the people that are making RFIDs are purchasing their antennas from China and Malaysia, actually shipping those to factories in many cases in other places, and then we'll do all the assembly and the attachment. When I'm talking about cost, it includes also the cost of this RFID antenna, include actually all the depreciation costs for a full printer or a full solution. So it has to be compared, of course, apples to apples. So the benefit is pretty immediate.
Got it.
So we have one question from the audience. For Copprint, what is the post-processing or sintering that's required for your conductivity results?
What is the post-processing? Well, there is no post-processing as part of the system. It was in the movie a big machine from Mulbar. There is a simple printing, drying, and sintering unit where I would say the cost of those is rather negligible relative to the eventual cost of running the material inside the printer.
Another question from the audience. You mentioned that the RFIDs are now compostable. Is that because of the small amount of copper that's necessary? What makes it compostable?
Well, the compostability, first probably to say relative to aluminum and plastic, we all know that they are not compostable, okay? With respect to the RFID antenna of copper on paper, we all know that the paper is compostable. And then there are the question of how much copper you have on a tag. Usually the average amount of copper in a tag is about 6 milligrams, which is the same amount of copper that you have in 3 chocolate bars, or in a half a kilogram of kale, or I don't know, 12 oysters, depending what's your preference, kale or oysters. Usually, maybe I would say if you take just this tag, it is the daily recommended value of copper for 4 people. So think about it every morning in breakfast. You can cut one of these tags, give to every member of the family, and you have enough copper.
That's awesome.
Oh, by the way, one thing that it is actually very important to say about compostability. It's a very big issue. We don't have time for it, but this is compostable in a home composter. You don't need to use an industrial composter with high temperature that usually do not really exist very much. This can work in standard home composter at low temperature, and that's of course a very good news.
Any other questions from the panel? That was an awesome answer, by the way, Ofer. I've never heard it compared to kale or oysters, but it is true.
Well, you can think about it like because a lot of people ask us, can I throw it to the garbage or to my composter? And I said, well, it's the same amount of copper, like I don't know, 4 gallons of water. So.
Right. All right.
Heidi was talking earlier about printing food. This is just another example of that. It looks like, Ofer.
Printing vitamins.
Well, but
yeah,
we all want electronics, and we need to understand the environmental impact of electronics, including the disposal. And I think it's becoming more critical to, especially today, younger people are paying a lot more attention to that. And we look on these big brands that we are all familiar with. And in many cases, they provide you tags. You can see this is a tag. You can recognize the logo. It seems like it's environmental friendly. Like they choose paper which looks friendly, and then inside you can see here on the tag you have this aluminum and plastic, and we have to change that.
So I know a lot of questions are continuing to flood in. I appreciate the audience participation across the board. There's a reason why we never have enough time for these things, but everyone is more than welcome to connect with Ofer after the fact. There's going to be a website with the contact information and whatnot. And if you still have any difficulty, of course, you can reach out to Dendrite. But I'd say in order to keep things timely and move on, I'd say thank you, Ofer, for your time. It's always a pleasure talking to you. And honestly, I think I can say every conversation I've had with you, I've learned something new. So thank you for your time, Ofer, before we move to the next.
Okay, thank you so much.
Cheers. All right, so the next company that I'd like to introduce and bring up is Saccade Vision. They are continuing in the trend that started earlier in the panel with regards to figuring out new ecosystems and ways to basically bring production to additive manufacturing. They provide a machine vision control system and a way to basically enhance quality control. So with that, I'd like to introduce Saccade Vision.
Manufacturers and industrial automation integrators are looking for a fast introduction of new products and inline quality control. Saccade Vision offers a cost-effective solution for three-dimensional quality control and robot navigation. Our machine vision provides the coordinate measuring machine level of precision, resolution, and robustness at a rate of hundreds of measurements per second, making it ideal for the inline process control. Saccade Vision targets multiple cases in the body and white assembly, final assembly, and the quality control of incoming components in automotive, aerospace, and electronics industries. Saccade Vision, focus on what really matters.
All right, Alex, thank you for turning on your camera and joining.
Thank you for having me.
Does the audience have any questions, or does the panel have any questions? All right, so then I'll ask a couple questions. I'd say over the course of 2021, Alex, what's kind of the key goal or go-to-market here? Is it essentially just working with the initial customers and making more case studies and proof points?
Yeah, so like was said by the panel earlier today, we would like to get the clear product market fit and come up to the next investment when we have we have a good understanding of who are our customers and why they are paying us. So we're starting now. We are developing our market now. Actually, next week we start a program with one of the largest manufacturers. I hope we will be able to publish that next week. And it's a startup program. We also start integrating our solution with a European manufacturer of metal forming. And we also expect to start integrating that with plastic injection molding machines.
That partially answers, I guess, the question that I'm getting from the audience. Basically, who's your target market? Is it essentially the machine manufacturers, or is it end users, or is it both?
We have actually, there are two types of customers for us. One is system integrators for the industrial automation industry, machine vision integrators, those who are doing projects for contract manufacturers. And this is mainly for the automation, and for the machine integrated inspection, this is OEMs.
Go for it, Arno.
Thanks. Thanks, Alex. Thanks for your presentation. I have a question also regarding the use case for additive manufacturing. When I think about that, I see maybe the unpacking and sorting of parts that come off a build tray. So we have trays with hundreds of different parts. And then the big question is, can your inspection systems only look at the contours, so the outside of the system, or also do they also see the complex inside? Because this is where most of the additive manufacturing magic happens. And the second part of the question is, if we are identifying, let's say, not totally different parts, but just an application like customized eyewear, so just marginally different geometries that all look alike, but they need to be assigned to the right customer order. How well can you differentiate between the parts?
Okay, so I will answer it. So the first question, yeah, so we have, this is an optical technology. So we obviously, it's not an X-ray. So we obviously do not see the oblique, inside oblique objects. We can imagine ourselves, but this will not be our first application. We can imagine ourselves being inside the additive manufacturing equipment and monitoring layer by layer. But again, I don't think this would be our first or second application. To be frank. So regarding your second question, we have a resolution which is roughly 1/10,000 of the field of view, and this is really remarkable for this kind of technology. We can capture the field of view and focus on a very, very small part. So we need to pay for that. We pay for that by having a local inspection. So if I know where to scan, I can scan and resolve really, really small features. Just to, if we talk about 100 millimeter field of view, it's about 10 micron resolution, but we focus on a certain locations.
Okay,
so
and for this, the part always has to be in a very fixed position. Then.
No, that's we actually can pre-scan with low resolution, and this is exactly what is this technology or this product is about. We can pre-scan with low resolution. We can find the location of the part in 6 degrees of freedom, and then we can focus on the important location with really high resolution, and and do it very fast.
Okay, good, thanks. So there's a question from the audience about time and how long the scanning process takes and the robustness of it. Do you have a relative time scale between your software hardware solution and potential other competitors?
So if we compare apples to apples, and we do the full body scan, we will do approximately comparable to our competitors, with the one exception that we can scan, we can keep both parts and sensors static without moving them as in typical scanners. And this allows us to get better precision by not introducing vibrations or mechanical inaccuracy. However, if we are focusing on small parts, then we can reach really up to 500 measurements per second of local measurements with high resolution. So it will be much faster.
And how does the system, as in terms of picking up different things like weld, splatter, or grinding marks? Like, can you give a comment on that?
So one of the, I'm not sure specifically about welding, splatter, or grinding marks. We need to obviously test that. But one of the major advantages of this product or this technology is that we can adapt the acquisition pattern or acquisition parameters at the level of a single pixel. So that means that we can, if we have highly reflective material, we can change the parameters across while scanning and locally and get the best imaging quality. And the same goes for other materials. So if we have a very bright and very dark material, at the same time, we don't use the same illumination or the same scanning for the whole field of view. We adapt that to a specific location, and this helps us to be more robust in terms of scanning of some more difficult parts. I hope that answers the question.
I think it does. We're about to change now companies. I'll give the panelists one last opportunity to ask a question. Any questions? Okay. Well, thank you for your time, Alec.
Thank you very much.
It was a pleasure, and I wish you the best of luck. Moving on, we're going to now kind of pivot a little bit more into software. So continuing the theme that kind of Amar started in the initial panel, right? Clearly, I think the future of additive manufacturing is personalized and industrialized, and Twikit essentially embodies the enablement of that through their software solutions. So with that, I'd like to introduce Twikit.
Hi, we're Twikit, a B2B software company in the space of digital manufacturing. We work for leading brands, and we are here to help them tap into the value of product personalization. How do we do this? Well, we connect their customer touchpoints, e-commerce, 3D scanners directly with digital manufacturing factories. And by doing so, we enable advanced product individualization at scale. Thank you.
All right, Martin, thank you for turning on your camera. Are there any questions from the panelists to kick it off?
Just a quick one on your automotive applications. I guess you'll obviously be, are you defining it with the OEM in terms of what areas are available for customization? Obviously, when you're talking about automotive grade parts or customization that may change dash configuration, for example, for crash, etc. So are you defining that with the OEM, which I assume is how you go about picking the parts?
Yeah, sure. Good question. Yes. So basically, the OEM is defining this as they do the product development. Obviously, we can assist with this, but yeah, things like crash testing, that kind of stuff, simulation is all part of the exercise in bringing in customization in automotive. Yeah.
A question from me on the kind of the customer experience and how that relates to what role you play in here. I presume, I mean, the customer experience is very different from picking options for a car versus defining a sole insert or an orthotic or something like that. I'm just curious if you've run into any challenges with respect to the customer facing for such dramatically different industries, and then B, do you get out of the way once the product is spec'd? Or are you also involved in the continuing relationship in terms of like the time it takes for the product? You know, where do you draw the line in terms of what your application does?
Sure. So on the first question, yeah. So indeed, the customer experience is defined by the end user, and so there's a clear difference between a car buyer who goes online or maybe at a car dealer and a orthotic specialist, for example, in a clinic who wants more options. And through the years, we've really built a lot of experience on, yeah, what are the skills and what are the requests of these different type of buyers. But the good thing is our software is also, it's API driven there. So we have the API in the front end, and basically you can skin, you can also customize the customizer even and skin it, of course, with branding, but also how you see the different steps, and you can tweak it like that based on your industry and what you want. Secondly, on the second question, so yeah, so a product is inputted into our kernel, and so based on that, it's deployed to the front end, and the connection is made with the back end. Once that is done, it's running in an automated way. So it's also design automation. So that means if a customer orders something, configuration goes to the cloud, production ready file is generated, and it goes to a production factory, which is not, we are not involved in that part. Of course, we have customer involvement for next steps, which is often around, yeah, what are the next products to be onboarded in the platform, that kind of stuff.
So let me just ask a further question on that, because I'm just a little confused. Like, for example, when you're ordering a car, a lot of times you may want something, but the delivery date, you know, there's a trade-off between what you want and how long it takes. Sure. And I'm just wondering, are you in that feedback loop as well?
Yeah, sure, we are. Yeah. For example, in automotive, we are integrated with the ordering system for the car. So we need to make sure that we need to know when the car is manufactured at the factory, because the parts need to arrive there.
Right.
We need to make sure when the customer can order customization. So, for example, for a European OEM, that's 6 weeks. 6 weeks after ordering your car, you can still order customization, and then it stops. But we have deep integrations with these kind of systems to make it work. Yes. Okay,
so if I click on I want the purple leather seats, I immediately get the feedback that, well, if you want this, it's going to delay. This has an impact on your.
Yeah, you get that feedback. Yeah, sure. There's a delay. However, maybe there's some differences there between regions, but obviously customers understand when they order advanced individualization that they need to wait longer than just have a car ready from the garage. But we are definitely integrated with these kind of parameters. Yeah.
Okay. Thank you.
You're welcome.
Martin, can you elaborate on how you're disrupting the value chain between the OEM to the customer and the impact to your TAM and the opportunity overall?
Yeah, sure. Impacting the value chain. So we make it shorter. So if you have parts today for a car and they need to be individualized, they can either be produced by the car OEM itself or by tier ones, tier twos. And then of course on the front end, we have the link to the car dealer, the e-commerce, and we can make the fulfillment chain really short. So I mean, if the tier one or the T2 would do the actual manufacturing, we can shoot the file all the way to the end. So I mean, that's transformation. The chain gets shorter. The impact we are bringing on value, I think, is on two levels, James. So we have on the top line, of course, a big thing of personalization is that it creates value. And as mentioned in the presentation, people are really willing to pay up to 25% or more. And depending on the type of car or the segment, up to 65% of car buyers are really keen to tap into the individualization. So this creates a huge business case. so that's the one side. And the other side we see is that for car OEMs, modularity is important. So you want to have frames for your cars, and you want to take them for a long time in your manufacturing flow. And you can actually use digital manufacturing to integrate modularity in your systems. So maybe do the final tweaking or the final personalization of your car later in the process. And so you win a lot of time, and you win a lot of flexibility there. And also on this level, we see that we bring a lot of value to OEMs.
Harshal, if we still have a minute or two, I have a couple quick questions. So
sure.
Thanks for the presentation. One of the things that has hampered configuration solutions or knowledge-based engineering in the past is being able to do it at scale is difficult because, for example, the golf clubs that you showed or a Bentley car, they all have different rules around what can be customized, what can't be customized. And in the example of the purple seat covers, that's all ERP sort of information about how long is this going to take or that going to take. So number one, how do you guys help each of these manufacturers of items be able to quickly get their rules embedded into the system? And the second question is downstream. You mentioned connecting to the industry 4.0, and you referenced creating a production ready file. What's this production ready file? Is there a new magical format that all of the machines speak that I'm not familiar with?
Yeah, sure.
Sorry for combining the questions. I just wanted to get them.
Good questions
on the table.
So on the first level, I think a clear differentiator we have with Twikit is that we have our own kernel in the cloud. So we're not a CPQ solution. I would, for example, compare it, we are the software is template driven. So, and I think we showcased the product creator in the presentation, and there are templates. So of course, if we have templates in our modular architecture, it's easy in the software to say, okay, this is, for example, a car part, or this is indeed, you're completely right, this is a medical brace, totally different differentiators, but maybe also totally different technologies, totally different minimal thickness. And these kind of parameters, because we have the modular architecture in templates, it's easier to define them and to click them. Mm-hmm. So and that's really an important step indeed in scalability, because of course it would not be feasible to hard code all of the parameters inside a solution. I mean, that's possible from a technological perspective, but not in the business case. And then on connecting with the manufacturing ecosystem, I can maybe highlight where we stop. So also there we have an API, but typically you would call us, if you compare it to 2D printing, a pre-production software. So we will shoot out an STL, for example, together with a production briefing. We can shoot out a 3MF, or we can shoot out a 2D file, but all of the other operations that happen to bringing it to a printer, we connect with partners for that, or often that is part of an existing manufacturing solution, if you know what I mean.
Yeah, so each of the clients you work. Sorry, go ahead, Harshal.
I'm sorry to say this, but time is up. We didn't actually even get to any of the audience questions, so I know a number of people might be frustrated. I'd encourage you to ping Martin through the chat window directly, or connect with him with LinkedIn. But in the interest of time, I'd say, Martin, thank you for presenting, and thank you for your time today.
Thank you so much. Thanks.
All right, I'd like to introduce our next company, MakerOS. They are another software solution provider, again in the vein of bringing additive to a production capacity. So with that, MakerOS.
Hey, how's it going? My name is Mike Mosheri. I'm the founder and CEO of MakerOS. We are the foundational business infrastructure for modern day fabricators and engineers. Follow me and I'll show you what we're all about. To start things off, let me tell you a little bit about us. So over the last 11 years, I've been starting companies and building products mainly within the additive space. where in 2013, I co-founded one of the world's first additive retail spaces out of Chicago, and then later founded another one more focused on aerospace, medical, and automotive out of Detroit. And we have over 15 years of management and software development experience with our CTO, Joe, and over 10 years of marketing and growth experience with Carlos at other venture-funded and exited companies. Let me paint a picture for you. Our mission at MakerOS is to support the next generation of makers, engineers, manufacturers, designers, and fabricators by providing them the foundational business infrastructure for modern product development. We believe that every maker should have access to the software tools to facilitate their design, prototype, and production process. We combine those tools in the MakerOS platform so it's easier for makers to build and operate a successful business. We believe that access to these tools should not be cost prohibitive or complex. So here's how MakerOS can help these businesses. We allow them to make more and spend less on their business, where they can increase 20% of their margins by reducing the software bloat by taking out those 6 different applications that it typically takes to run their business down to 1, with an annual savings of $50,000 or more. We also allow them to collaborate better with their team internally, along with their clients in the client portal, to reduce project timelines by under a week with 0 data silos, so that you have a clear paper trail of everything that's going on in your business, while also increasing the value of your service with the customer experience with a nice online portal for both your team and clients to use. We also allow our businesses to connect with other suppliers within the MakerOS platform so they can build supplier relationships that last over the years, while reducing churn on their clients, so that anytime the client needs something that they can't offer in-house, they can overflow that work to another supplier. Let's take a look at all the different aspects that are included with the MakerOS platform. We have a CRM directly within MakerOS where you can track all of your customers and export them into any other system. We also have a project management system where you can build your own workflows, along with CAD inspection, along with a collaboration portal that allows your clients to log in directly and create projects so that your team can communicate and collaborate with them online. We also have a full online building system directly within projects and an automated quoting system. We are also introducing a project marketplace so that suppliers can bid on different jobs and share their projects peer-to-peer. We are also creating a supplier networking module that allows suppliers to build their own private supply chain directly within the platform, along with storefronts, which will allow them to sell machines, supplies, and any other sort of commoditized part into the marketplace. These last 3 concepts are what we call overflow, and this is coming in 2021. Not only is overflow my favorite word in the dictionary right now, but in 2021, once it's live within the MakerOS platform, it will allow for every single participant within the network to have access to the capacity of the entire network, so that you can explore and find other suppliers to work with, and also offer your service within the network to open up an entirely new supply channel for yourself and your business. Starting in January, MakerOS is operating as a freemium model, where we have a premium and a free version of the software that goes directly to the supplier, and the supplier builds their business directly all around MakerOS. And when they have clients that come onto their platform and transact with them, MakerOS makes a small percentage fee on each credit card transaction within the system. Now let's imagine once Overflow is live for a second. When that is live, we will allow for direct supplier-to-supplier interactions and transactions while they're working on the same project. So now imagine all of those transactions throughout the entire life cycle of a product and all the different suppliers that exchange hands in the development and execution of that project. That's where we need to be, and that's exactly what MakerOS is going to dominate. As you can already tell, MakerOS is so different from all the other competitors within the additive space. We're not just additive focused, but we're encompassing everything else in engineering and design. And our clients are the ones that are actually competing directly with all the large manufacturing as a service companies that are out there. We are also complementary to a lot of the other software systems out there, including ERP, CAD, PLM, and other manufacturing execution systems. MakerOS is also compatible with a lot of other OEMs that sell machines or materials. This allows for any of our customers who use MakerOS to integrate any other type of manufacturing technology within their quoting system or any of the materials that these companies may sell. All right, thanks for watching. I look forward to hearing from you soon. See ya.
Alrighty, Mike, thank you for joining the camera. I'll let the panelists ask questions first, if you have any.
All right. Nice to meet you, everybody.
All right, so I guess maybe I'll force James to ask a question. So I think this conversation around overflow is actually pretty darn interesting, right? Because most people don't realize that when you send a job to be manufactured, there's a good chance that the person who's doing the manufacturing might not actually have enough capacity to do the full volume of what you need.
That's
And
right.
then that
I actually have a great project example for that, if you don't mind me kind of expanding on that.
Go for it.
So we had one of our clients out of Brooklyn, and they were primarily an FDM shop, and they had some SLA machines. They had a client that needed some filtration parts made specifically at volume that was really only suitable for SLS printing. So we beta tested this, and we helped connect one of our other suppliers out of Chicago that has multiple EOS P110 machines, and they were able to fulfill that work and collaborate directly within the platform together on that and for the fulfillment for the original client. And as myself being a fabricator, over the past 10 years, this is something that practically everybody does. Everybody tries to overflow work from one of their suppliers if they can't do it. And that's a very typical type of transaction. And that's usually done outside of the usual workflows of the existing infrastructure that the company may use. So if you can condense the customer interaction and the supplier interaction in the same place, there's a huge X factor on top of all that. And especially for us as adding value for all the transactions that go into developing products.
I'd like to better understand your customer and your business model. Right?
Sure.
You kind of alluded to the customers, but I'd really like to hone that in and how you drive monetization in business.
Absolutely. So with the freemium model, we obviously have, this free version, which incentivizes, low risk and, very, very rapid onboarding of different clients. Because obviously in this market, a lot of people, you might have to go through purchasing departments and having them going through, all the loops in order to get onto a platform. So if you have a version of that that's easier to get on and use, it'll hopefully be easier for them to start onboarding their clients. And as soon as the transaction happens, we use Stripe Connect. It's basically the same platform that Uber and Lyft use in Shopify for their transactions. So anytime, let's say if there's a $100 transaction, there's a 2.9% plus 50 cents taken from that transaction that goes to MakerOS. So it's at a level that's appropriate enough and manageable and comparable to a lot of the other online platforms or e-commerce platforms out there. But we also have a premium version that it basically encompasses more capabilities within the platform and capacity in terms of file storage, amount of project boards and workflows that you can create. So there are versions that are more appropriate for larger companies. So there's the freemium with the transaction fee model, and then there's the premium subscription along with, there's still a smaller transaction fee taken out of that as well. So it's more of the business that is using MakerOS, which would typically be a small fabricator. And our identification is that, it's specifically in the United States of who we're targeting are fabrication shops, 20 employees or less that have, multiple different customers and projects on an ongoing basis. And we are the ones selling and providing the infrastructure for those businesses. And they're providing the service to really whoever. I mean, our customers deal in, medical, aerospace, consumer electronic, everywhere. And the amount of services they offer too, this is a very important distinguisher between MakerOS and other platforms, is that practically all of our services that use MakerOS or suppliers will offer engineering services or other services beyond just additive. And that's an extremely important beat to hit when you're building a solution like this. You can't be extremely vertically focused. You have to be compatible and complementary to a lot of the other services that a supplier may use as part of their tool chain. I hope that answered your question.
Yeah.
All right. So I guess the question from the audience is the supplier side interest in the overflow platform easy, right? And I mean, I guess a number of people are asking how you're essentially difficult or sorry, different from or complementary to like your traditional MES system. For those in the audience who don't know what MES is, it's a manufacturing execution system. It's a type of ERP software that businesses use for printer fleet management.
Yes. So overflow, the concept of overflow, being able to have access to other capabilities from other suppliers and building that supply chain has been the #1 requested feature of MakerOS. And really is actually the entire point we even exist as a company, is to build that network model. And our strategy has been very Trojan horse, where we build essentially all of these nodes that are using MakerOS today. And once you activate the network model, all of a sudden you have all these suppliers and built-in, baked-in capacity. It's somewhat similar to, I guess, Tesla model of having, cars with some autonomous features on them. But once the software and network model is available, then, Elon basically said he wants to have, robo-taxis type services baked into his vehicles. So there's other comparables to that type of transition type of model that we're following.
All right, I guess another question is, how is proprietary knowledge or data stored and protected?
Yep. So, everything is cloud-based, and everything within the system has permissions baked in. So whoever has access to a project, to specific files, and it's somewhat typical towards a like an Asana, where you have user permissions. But on the client side too, you have specific permissions towards specific customers and what you want to allow them to see or have access to, whether that's a slice file, G code, a 3D file, a quote, an invoice, an estimate, whatever that might be. But we also have 3 different available versions for enterprise, which with 3 different deployment options. So if intellectual property, and let's say for ITAR compliance or something like that, there is a possibility to basically deploy MakerOS on GovCloud through Amazon or something else that's more localized as well.
All right. Another question is, I guess it's in the same vein. In the medical side of things, how do you deal with validation liability, et cetera?
Yes. So for HIPAA and those sort of things, we don't currently use or have many suppliers that are doing that, because there's so many, red tape. So that's not really one of our beachhead markets that we currently are going after for medical, in terms of anything that's more HIPAA compliant. For things that don't require that, we do have some suppliers that might make some certain parts for other machines that go into a medical device or something like that. So that's kind of where we're at with that sort of thing. But as I mentioned, if there were requirements for certain data security or validation, there's the possibility of spinning up an entirely different system of MakerOS for that specific industry. So not only can we do that for specific industries or requirements, but we can do that same thing for, let's say, an OEM who wants to spin up a specific network for people who use their types of machines. That is also a possibility as well. So imagine all these different nodes of micro networks and macro networks is really what we envision overflow can be.
That was actually going to be my next question. For example, I know HP in particular has a HP like manufacturing network, which specifically meant to tailor to, at least initially, HP machines, right? Would the idea be that you would be able to connect into that and be another node in that network?
Absolutely. So if it needs to be a private network for specific applications in that context, absolutely. We even see the application beyond in the future of even partnering with governments for other areas of the world that have more direct government involvement and want to see a master dashboard of production capacity, who's doing what and partnering with who, and basically building this engine of collaboration and just getting stuff done. And that's to say too that if there were HP network that could feasibly connect towards an ITAR network, or could feasibly connect to an EOS network or what have you. So it's fairly adaptable that way. It's just how you build the pipes in between.
Okay, I think we're at time now. So thank you again for your time, Mike. I appreciate it, and I wish you best of luck. And again, as always, there are a bunch of questions coming in. I'm trying my best to get to all of them and read them at the same time. So please do, again, follow up with Mike on LinkedIn or in the chat. Thank you for your time, Mike.
Thank you very much.
All right, the next company I'd like to introduce is Adaptiiv. They're again continuing in the trend that Amar kind of prophesized at the beginning of the panel, but this time more on the personalized side of things, specifically in medicine and cancer treatments. So with that, I'd like to introduce Adaptiiv.
Adaptiiv is a medical device. We are the world's first turnkey, regulatory-cleared software solution for radiation oncology. We enable the automatic design of patient-specific radiation therapy accessories created via 3D printing. This improves treatment accuracy and patient experience while reducing the common risk of failing to deliver the patient's treatment plan as designed.
Alrighty, thank you. Let's see. Hi, Alex. I think you wanted to share your screen or share something.
Yeah, hi everybody. Thanks for having us. I just wanted to share a few parts. It's really interesting to see some of those parts on screen in the video, but really just wanted to show you just some of the personalized medical devices that we would be 3D printing at point of care or through parts of service. So this would have been a scalp bolus. What really this is aimed to do is attenuate the radiation that would be delivered to the patient, pulling the dose up close to the surface of the skin and really helping to spare healthy tissue in the brain. So this is a pretty common product that we would see used in cancer treatment. Another one is this would be for a chest wall. So we have a patient going through a post-mastectomy when you have breast cancer and there's some cancer tissue remaining on the surface of the skin. And really what this is designed to do is to really pull the dose again to the surface of the skin to ensure any remaining cancer tissues are eliminated. Yeah, that was really it. I just wanted to show you a few of the personalized parts that we do manufacture and just really open it up to everybody who has some questions for us.
And first question, super easy one. How much have you raised so far and how much are you going to raise right now?
So to date, we've raised just about $9 million. About 25% of that is non-dilutive funding. Happy to sort of chat offline about what next steps look like for us in a one-to-one. But yeah, we have plans to start a round of fundraising first half of this year.
Okay. And can you talk a little bit about, I don't know the market well, so I'm just trying to understand the importance of time. How long does it take for you to deliver a part to the customer versus the in-house bespoke current methodology?
Very good, very good question. So today, conventionally, you'd have mold rooms in the hospital that are using wax and molds and various other things like gauze and tape. We have patient experience is really critical for us. We have a lot of clinical folks that work here at Adaptiiv. So yeah, we've seen cases where you're 3 to 5 days conventionally preparing a bolus like this. You've got a real complex anatomy. You've got the patient's anatomy changing over time during treatment. So, really digitizing this process is really what drove the early beginnings of our IP. And that's really it. So, we see massive improvements in time savings, I guess, within the clinic. Very good question.
Thanks.
So Alex, I spent a bit of time in the medical industry before doing automotive. And so first, I think you've done a great job in just getting the interest across the medical field. That's not easy. So your FDA cleared. Another question on time, actually. It does take a significant amount of time to really get people to commit to an ongoing revenue base for you guys. So what are your thoughts around that? I saw some of the revenue projections from the slides, but how do you really make it happen now that you've got, parts out there and you're testing?
That's right. So, Adaptiiv was really milestone driven. We were really focused on, marquee clients. And we never really thought about just the technology. It was really about the whole end-to-end solution application in the clinic. And what did we learn from those marquee clients? From onboarding to the technology and making sure it was hardened for them to use. And then the adoption. So, we're really focused on the last, 4 or 5 years of that. So we really have a good understanding, a deep understanding of what happens in the clinic, what's required of the part to turn around. So really everything at this point has been about us getting to a place where we're ready for scale. Feel we've got the product, the IP, I guess the technology, we've got the partnerships with HP. We really, at this point, for the current part of the service, we are agnostic and we can use other technologies. If a customer is looking for a different 3D printing technique, we certainly can do that. So, really we've established ourselves to be ready to start taking part of that 500,000 parts you saw, I guess, that sort of unencumbered view. There's a long road ahead. We have a lot of challenges. We've got a lot of great partners on the 3D printing side, but also we've worked really hard in the radiation treatment ecosystem. So the healthcare providers who are delivering the treatment in-house and just really working on API integration, product compatibility, things like that. And really getting to the end user, the cancer centers, through those channels is really going to enable us to hit those scale numbers.
Great. And just quickly, when you think about scaling that globally, because this is going to be something, I think, if you're successful, this can go everywhere really quickly. Is that where HP is coming along with the ride, or how are you thinking about that as you start to scale?
Very good question again. We're outside of the US. Actually, we really started in Europe, in Australia. So we've got a lot of experience scaling outside through channel partners. We have a lot of strategic relationships already formed with leading partners in various regions. Starting to emerge a little bit, moving forward into Asia, and then into the United States further with a new solution portfolio. I'd say as we look at a relationship with someone like HP today, really what that enables us is to take the part as a service model globally. So what we've recognized is that we have the ability to turn parts around in 3 to 5 days today. We feel we can improve upon that basically to anywhere in the world. And really starting to get the attention of some of the larger cancer networks, starting to reach out. So we're really excited about where we're going from here, and how do we, make sure that the patients are getting the best personalized devices every day. So
great, thank you.
Harshal, do we have time for another question?
Yeah, and I'll ask one, and you can tack on to it. I'd say, Alex, are you looking to partner with other OEMs besides HP, like 3D Systems, EOS, or maybe on more on the medical side? Because I know HP is primarily polymers, but are you interested in partnering with other OEMs on the polymer or metal side? And I'd say, Ron, ask your question too.
Yeah, do you want to ask?
Go ahead, Alex. No, go ahead, Alex.
Okay, yeah. Because we're so close to the clinic, and our solutions are built there, we really take the pulse of the market. So we really have a deep understanding of what the end user needs for their patient, and that's really driven, how we've reached out to partners like HP. So our position today would be that we've got a solution in market, we've got current clients. We're looking to bring the right partner with us to service that market. The scope is, can only be so wide when you first start off, when you're a startup like Adaptiiv is. I think we've demonstrated we've had a very good track record of being effective within that scope. So I think for us, we're really going to let the customer help us drive that. And when the technology prevails, we will look to bring the latest and greatest technology. Working with a group like HP, there's a lot of stuff that they have as well that's really going to enable us going forward too. But if other partners emerge, we are certainly open to that. Customers are ultimately the ones who demand these things. And in our market, you have a patient maybe who would have surgery that might require different material on the surface of the skin, or intracavitary inside the body. So really, for us to really, be exclusive, it can be challenging. We need to be careful of not tying our hands there. So, we intend to be, pretty wide open with who we work with. However, if it makes sense, we'll be strategic when we can. Great question.
I know we're short on time, so I can offline my question to Alex. It's no problem.
I'd love to hear it. I will share one thing before, I guess, Harshal, if we're wrapped up, I would like to share one thing. Everybody's sort of signing off. We're pretty, I guess, excited to be able to work in this space. One of the things that we do, get to see a lot that some people really don't day to day is just, the patient comes. So I just shared an image here for you guys just to have a look at. So this is one of our latest and greatest patient-specific applicators for intracavitary gynecological cancer treatment. So in this case, we had a 7-month-old who was born with cervical cancer. Through our ecosystem with RT OEMs, no one was able to treat the patient. The group in Puerto Rico reached out through the OEM in our space. We quickly designed, printed, and shipped various medical devices down for this. And this is a picture of the patient that was able to receive treatment with a personalized medical device. It really hits home for us. We're really proud of the things that we've done and been able to accomplish today. More stories like this lie ahead. and personalized medicine and digitization is really important to making those things happen. So just want to say thank you, everybody, for having us.
Thank you, Alex. I appreciate your time. Yeah. All right. Then moving to the next company with Gusto, I'd like to introduce Link3D. Link3D, again, is in the same vein of the production software side of things. They provide a manufacturing execution system and allow users of machines to essentially scale their printer fleet management. So with that, I'd like to introduce Link3D.
Hello, everyone. My name is Shane Fox, and I'm the CEO and co-founder at Link3D. I'm here today to tell you how large-scale manufacturers are achieving a return on invested capital with their additive manufacturing environments by enabling and adopting Link3D's software platform. So I have been in the industry for the past 10 years. I started my career with a software company named Within Technologies, where we were focused on topology optimization. In 2014, we were acquired by Autodesk, and while at Autodesk, I was leading additive strategy for the Office of the CTO. Now, while I was at Within and while I was at Autodesk, I was very fortunate because I was able to work with some of the largest global manufacturing customers across the planet. And when I was boots on the ground with these two companies, the same type of questions were being asked to me. And they were, how do we best operate our machines in our day-to-day supply chain or our day-to-day manufacturing environment? That's when it became apparent that our industry was focused more on the investments in and around the additive machines and less on how the machines will be managed at scale and potentially even optimized in the future. So in 2016, Vishal and I launched Link3D to build a software platform that would enable these additive machines to coexist in an enterprise's network of systems, suppliers, and its customers. Now, Vishal and I have been very fortunate. We are working with some world-class enterprise software professionals. Mike Jones, who came on as our president and CFO, he's been an executive at several Fortune 500 companies. He's founded and ran several of his own software companies. He's a large investor in Link3D's business and a prominent angel investor across Colorado. Jim Carlson, he's the head of our customer operations. He has made a living, he has built his career on helping the companies he goes to work for and run, setting up successful joint customer operations teams. And Mark, who's heading up sales and marketing for us, is a former sales exec at a software company called Datalogix, which was acquired by Oracle. And while he was there, he took one of their flagship products from 0 to 100 million in revenue in just a few short years. So we're very lucky. Link3D was founded in 2016 in New York City. In 2019, in the beginning, we moved our company out to Boulder, Colorado. We still have a presence in New York and New Jersey. We have also in Japan and as well in Germany. And our core team, we have over 50 years of additive experience, so we really understand what it takes to scale, to move into production, and to achieve that return on investment that almost everybody is seeking right now. The business has raised $10 million since 2016, and we are actually in the middle of closing our Series A this month, and it will be a trailer. So we'll have a trailing investment that will be filled by the end of the quarter. So what is Link3D's mission? What is the purpose? What are we trying to achieve? We want to enable the rapid progression of the industry's maturity process. So like subtractive manufacturing and like the computer operations industry in the past, they were able to go from a managed to an automated state and break down that brick wall that you see here. The computers operation industry has gone as far as having lights out data centers, which is more on that predictive state. That is where additive needs to get to. If additive wants to be a viable player in the manufacturing supply chain, we have to get it over the hump. And to eliminate the barrier that you see above, we strongly believe that we need to start eliminating the human intervention in manufacturing processes, particularly in the manual movement of data from one system to another. We need to automate the capture of all of the data generated across the entire manufacturing process from end to end. And eventually, Link3D, our big, hairy, audacious goal is we want to power the factory of the future, or the lights out factories of the future for additive manufacturing. And we knew to accomplish this change, it was going to be necessary to get the machines to open up their systems to Link3D. And traditionally, unfortunately, the machines have been very closed. So they were not very open to collaborating with not only us, but even with their own customers or any other players in the space. But in 2019, we had some good success in closing several manufacturing stalwarts. So you can see our marquee customers on the left and the right here. Because these customers had very long relationships with some of the largest machine makers, we were better able to articulate why opening up their systems and sharing the data with Link3D was necessary to help their customers and our customers achieve their vision of digital manufacturing. So as a result, we have been able to accelerate our connectivity strategy for the industry and our mutual customers. And I think one of the things I'm most proud of is that the machine makers, because they've begun to work closely with us, they've become paying customers of Link3D. They have benchmarking and they have print services, and Link3D is powering them. So in summary, you can see that Link3D is well positioned to help the manufacturing organizations achieve the sought after return on invested capital that they so badly need for their additive manufacturing environments.
All right, let's, I guess, begin the Q&A portion of this. Do any of the panelists have any questions?
Yeah, just a quick one on the predictive manufacturing. That's an area that we focus heavily a lot on. Of course, you're getting the data, which is great. So what does your team look like in terms of the necessary machine learning or AI approach that you're going to use around that?
That's a good question. So hi, everyone. I'm Shane. So part of the IoT strategy we have is to initially, get in and be able to collect that data. Right? So there's a lot of companies in the space that, that may compete with us that claim some type of AI or some type of ML, but I think we all know that you need to collect, a good amount of data, whether it be historical or real time. So part of the strategy is now that we have developed a platform and the gateway for connectivity, we start actually ingesting this data. We're looking at things like, how can we predict predictive maintenance on the machines, right? So that's a big issue in the space, right? Machines go down, they don't understand why. Your machine may be down for days or hours. So looking at the predictive maintenance, we're also in the future starting to look at predictive orientations, predictive, being able to suggest to build prep or CAD systems, optimal orientations, optimal support orientation for, metal and some polymer as well. And then also starting to look into how can we enable the most optimized utilization of the machines, whether they're in one site or in many sites based on historical and statistical information. There's some other things too, but that's the general premise of what we're moving in the future when we talk about ML.
Makes sense. Thanks.
You're welcome.
Any other questions from the panel or the audience?
Yeah, Shane, this is James. It seems like you really require a lot of key data from the various OEM manufacturers, right? And so we know that people aren't really super open with just giving away that data. And we are working with you, and I know others are. But how do you keep that relationship really strong? And because my concern is what happens if they start trying to bake their own systems or want to re-silo? How does that impact your ability to address the market?
Hi, James. That's a good question. So, I think one of the key things that we focus on is, our joint customer operations team. So we have Roxanne Warren, who's the head of our strategic partnerships, Jim Carlson, who's the EVP of Ops. And I mentioned it in the talk, but what we've done is we've leveraged our customers, right? So Lockheed as an example, right? And others to actually go to the OEM and say, this is why I need the connectivity. This is what we're trying to achieve with it. So after years of listening and, fighting, because the machine makers traditionally haven't been open, they started to really understand, okay, we don't want to be in this business, right? We don't want to be developing a connectivity or a gateway platform, an IoT platform. Also, the customers want to aggregate, right? So we all know, most manufacturing companies have multiple sets of machines, right? So, having just an HP machine is quite rare, just an EOS or just a Stratasys, it's a mix. So we also want to be able to aggregate that information for supply chain optimization engines and other factors. So, I think it's been, one is trying to deliver the value and the value prop to the machine makers, then getting them to use our system internally. Once they start using it internally, we work with them to build the optimal workflows around their machine in our software so that customers like Mitsubishi and Lockheed and Baker, right, have the most optimal workflow. They have the best utilization of our platform, companies like HP. So, at the end, it's all about the mutual customer satisfaction. And that's how we've really been able to develop this partner program with the machine makers.
All right. Any other questions from the audience or the panel? Let's see. A question from the audience: how does Link3D manage to keep its operation in Japan or Asia? I guess maybe a better way to frame it would be, how are you currently expanding in Japan and Asia?
It's not easy. I'll tell you what, it is not easy. So, the strategy is through partners and what Japanese call trading companies. So we actually have a VP, or our general manager, Wataru Mashimura, in Japan. And our strategy from Link3D side is developing partnerships and relationships with the machine makers and some of the best-in-class software providers, like let's say Materialize as an example. So by utilizing that channel, and we educate the market on why an MES and a QMS is important, right, for additive scale and become successful, we go through that way. It's been a slow grind. It's a lot of evangelism. So we're heavily invested, and we believe in the market, and we think it's a matter of time till the Japanese start really catching on to additive and moving into production. So it's a twofold strategy, through trading companies as well as through partners, if I answered the question correctly.
Cool. Well, I think we are going to move to the next company. I'd say thank you, Shane, for your time, and appreciate it.
Absolutely.
We're going to move to the final company of the day. So Fortify is an awesome company. Personally, I love their videos. If you haven't seen it already, you should go to their YouTube channel and find the one where I think their VP of BD or VP of sales literally takes a power drill to something. I mean, it's honestly entertaining, but it's honestly cool and interesting. And if you're a material scientist or a mechanical junkie, you're gonna dig what Fortify has to say. So with that, I'd like to introduce Fortify.
There are several high-growth market opportunities that require more performance than traditional unfilled photopolymers can provide. Fortify's goal is to open the aperture of what materials can be processed to unlock new applications using innovations across hardware, software, and material science. Fortify is combining a high-resolution 3D printing platform with unique and high-performance materials to meet these applications so that we can optimize for performance across strength, stiffness, and even electromagnetic properties.
Thanks, Josh, for joining. I'll give the panelists the first dib at questions.
I'm curious if you can just talk a little bit about your intellectual property and what role what you've done and how that could defend this.
Sure. Yeah. So I would like to, or I like to think that we have an IP vibrant culture at Fortify. So we have several families of patents with a number of filings within each group. Loosely speaking, I'll say that we have filed, been granted, and currently are paying to protect the hardware and materials techniques that we demonstrated today in different regions of the globe. And so we like to think that the first part of our moat comes in the hardware utility of using magnetics along with a printing process, the CKM system, mixing, meter mix, etc. And then another few key pieces on the interface material on the material side. And something that I realized didn't come through in the video that some might be wondering is that we can use our magnetic alignment process, FluxPrint, for inherently non-magnetic materials. And that's part of the IP as well as our process for allowing that to be possible.
Great, thank you.
Of course.
Joshua, really cool. We're using a polypropylene composite to basically remove the need for metal stamping and paint shops on our vehicles, body panels. So I'd love to just offline catch up with you on some of your tech. And also, how's your funding and what's sort of your next steps? So I don't know if it, wasn't really covered in the presentation.
Yeah, that's a fair question, and I would love to connect. I made a note of that. I think there's a lot of synergy between our two groups here, especially at the interface of removing heat from battery electric vehicle components. On the funding side, full transparency, we're in the process, or we're in negotiations now, or conversations to move to close our next round. And so if there's more, I would say, interest, I would welcome further conversation. I know we'll have a few breakouts here where I can get into some more detail, but we're eyeing up a round during the first half of this year that would allow us to continue to meet our go-to-market plans.
Okay.
Any other questions from the panelists? So coming in from the audience, I'd say, Josh, what are you personally the most kind of excited about from an application standpoint? Of course, you're selling to a broad variety of folks, but is there anything in particular that really kind of gets you excited from an application standpoint?
Yeah, so I was hoping I'd get a question like this, and so I queued up one slide. It's a very simple slide. I think that it's first to just go through our philosophy on where, Fortify believes the real value creation is within additive manufacturing, and it's at the intersection of, focusing your technology on an application area where you're providing a cost to performance or benefit or value creation that's off the traditional cost to performance curve, one that can meet the demands of production. So something that aligns with your ability to print in a certain number of parts at a certain throughput, certain tolerances, et cetera, and then one that really requires the types of materials that you can enable. So at our point, from our perspective, we have a high throughput light-based process, and we are now opening the door to these new materials that you typically can't service using 3D printing. And so for us, the value creation is focused on parts that we can make that other manufacturing technologies can't approach. And it's a long way of coming back to the original question, which is the most exciting application area that we're looking at today is at this intersection of electrical and RF performance within different types of connectors, lenses, and devices that are typically outside of the view of mainstream additive manufacturing, because these are components that require very, very complex geometries. What you can't really tell is that this type of structure can't be manufactured any other way, and it's made out of a material that can't be produced on other systems. So you have this very strong moat and a value proposition that really is hard to ignore if you're using traditional manufacturing methods. And so it's a pretty broad answer in the space of, we spend a lot of time making materials that are stronger, stiffer, tougher. I think those applications are great, and we'll continue to approach those, such as the injection mold tooling space. But when you're looking at a multifunctional material where it has some type of unique thermal or electrical performance characteristics, you can start to arrive at very unique value propositions using the strengths of additive manufacturing.
So I have another question about the magnetic alignment capabilities. I mean, in fact, that's the whole reason why a number of people asked us to reach out to you. It seems fairly unique, and it seems almost like not even a greenfield opportunity. It seems like a greenfield universe of things that you could control, given the number of things you could control with magnets. Can you touch a little bit more about this magnetic alignment capability and kind of where you see that type of technology going in the future?
Sure. So generally speaking, we are essentially surrounding a DLP build platform with a computer-controlled three-dimensional magnetic field. We can program each voxel within each layer if you're patient enough. But generally speaking, we're using this in the case of injection mold tools to align fibers against the pull direction. So if there's a mechanical problem you wish to have an optimal solution for, you can use alignment in that case. And in a similar manner, we're using that to augment electrical conductivity, thermal conductivity, RF transparency. And so as far as where we can go with this, starting to onboard new high value materials, for example, the radiation targeting component space is one that requires pretty unique performance and materials that can be programmed using this type of technique, and really focusing on scalability is where we're focused on going with that platform.
So speaking of scale, how does your technology or process scale with the size of the build platform? Right, that I'm assuming that's a common question you get whenever you talk to a customer, right? How big is the build volume? What do you have to say about that, and where do you see your machines going in the future?
Yeah, so believe it or not, I believe the more challenging energy barrier for scale is not the magnetics. And the reason I say that is we're using magnetics that are an order of magnitude less than what you would experience in, say, an MRI machine, and we're all pretty familiar with the type of build volumes that can sustain. And so from a scalability perspective, we're really focused on the light engine side. There's a lot of off-the-shelf solutions to get there. We currently have a build volume that's about 8 by 5 by 13 inches, and have plans to increase this over the next year. And so hopefully that gets to your main question there.
All right, any other questions by the panelists? All right, I'd say to wrap things up, Josh, do you have any other final parts or words for, honestly, any of the other CEOs or the panelists or the VCs? I mean, I'd say one of the key things that I've noticed in the space is, again, most of the venture community, quite honestly, isn't educated about the space, right? And that's okay. It's okay in this world to know what you don't know. And so, you know, do you have any parting words or maybe resources or things that, you know, you would recommend not only to fellow CEOs, but other venture investors who are listening?
Sure. I think something that will resonate with the audience today is that the shift for additive manufacturing has changed from the 2012-2014 timeframe of, you know, B2C commodity materials, everybody's going to have it, to more industrial use cases. And I think what isn't really being focused on is how different technologies specialize within those industrial use cases, and how you can really focus on value creation that can't be met with other types of manufacturing. And so if I were the investor, that's one of the things I'd want to know the most, which is, you know, what can your group do that other manufacturing methods can accomplish? And that's really what you can start to focus on for value creation.
Cool. Thank you for your time, Josh. I really appreciate it.
Thanks, Harshal. And thanks for the entire Dendrite team for putting this all together. It's been great.
Thank you. So I'd say to the other panelists, before we totally wrap up the event, are there any other final parting thoughts from any of the panelists? I'll just kind of go in the order on my screen. You don't have to say anything. James is already unmuted, so maybe he wants to go first.
Oh, no, I would just say, you know, just in response, we're looking at what we're investing in. We really need to look at adjacencies and things we can't address right now, right? So we are looking at, you know, solutions that are materials and other types of manufacturing. So holistically, it's an exciting time to be in manufacturing. And we are looking at how do we assist as a strategic investor, but also the second thing that we do is a commercialization of startup technology. And Harshal, you know what the power of that is about helping you scale in the marketplace. So we look forward to working with the startups here and the ones that have been asking some great questions as well.
Arno, you want to go next?
Sure. So first of all, thanks everyone for presenting. I'm really excited about the first of all the level of quality of all the presentations, and the competence level and the level of innovation that we've seen, which was really exciting. I think for me, I'm so happy to be in this industry exactly right now. I think it's exactly the right time. I mean, you guys all witnessed within less than 1 week we had 2 beyond $300 million transactions announced. The most recent one just today. So it's happening. This is becoming an extremely exciting year, and in an extremely sexy and interesting and exciting industry. So I'm convinced that the presentations that we've seen, the startups that we've seen today, are going to become really, really successful. And then I wish you all the best. Thanks.
Yeah, I think it's kind of fascinating that within the last 2 to 3 months, they think there's been over about $1 billion or $1.5 billion in M&A activity in this space just in the last 2 months. So clearly someone's excited. Say, Ron, do you have a comment?
I would really just echo everything Arno said. Great presentations, especially, and so much innovation happening, especially if you know the people who applied for this, but weren't selected. And so the competition was fierce to be one of the presenters. And it shows that a lot of the barriers to really digitizing manufacturing and the adoption of additive are being knocked down one by one. It's exciting to see.
Okay, Heidi, do you have any parting thoughts?
Yeah, in addition to what's said, I mean, amazing companies. I think that the number one thing that's always hard to convey in something this small is the longer range, the timeline, the business model, the economics. And I think those were a lot of the questions that, of course, as an investor, that's what you get to next, right? The most amazing technologies in the world don't make good investments if they don't also create amazing businesses. So I that's always the next step. I don't know how accessible everybody is and all that, but you're always welcome to email me. I'm Heidi at threshold.vc. And I just applaud you guys I mean, across the board, all the companies were really high quality. So thank you.
Avinash, any other parting thoughts? Seems like some business development opportunities happened.
Yeah, there's a couple of interesting stuff here that I'll be following up with. And I think that's the point, right? So great companies. I think when you look at, for the venture capital base, when you look at, what are some of the key frontiers and where are some of the established players going to find their next part of their revenue model or their margin, it's going to go down to how these products are manufactured. So I really feel like that's where you're going to see a lot of innovation happen, driven by, new startups that we've seen today, but also folks that are looking for where do they generate that next bit of efficiency, and technologies like this will start to light up. And I think, for the VC base, it's a very important time to back some of these startups, obviously according, as per Heidi, to really understand the business model, et cetera, post this, but there's really a lot of opportunity here.
Awesome. Well, thank you. I want to say a round of applause and thank you for our panelists. I know you guys are busy. You probably go to a lot of Zoom meetings every single day seeing people, but I really appreciate you taking the time to ask questions, ask pointed questions, and contribute your knowledge and expertise. So thank you.
Thank you all.
Thanks for having us.
As a reward for everyone who stuck around to the very end, I want to take this opportunity to announce that we're going to be hosting our next Dendrite Developer Conference event, basically April 20th. We're going to invite all the companies on our developer council and more to come and present at this event. A number of products are supposed to be launching at this event, so everyone should be fairly excited. I also want to take this as an opportunity to say we always get way too many applicants, and it's really difficult figuring out who to pick, who to not pick. It's my assumption that we're probably going to get another encore to go do this again, because I think we've gotten some pretty positive feedback from the VCs and the startups across the board. For reference, if you're a VC, a number of you get the investor guide that we send out, which is supposed to kind of consolidate all this information. So this is truly an event to help you. This is meant to be philanthropic. In that vein, if you are interested in sponsoring, similar to HP, an event like this in the future, whether you're a VC or an established enterprise, we're more than happy to continue to work with you. You'll obviously appear in the panel, and hopefully you'd find some value. And yeah, thank you all for taking time. Hopefully this wasn't a commercial about Dendrite, but hopefully this was valuable for the overall industry, and you came out of this at the minimum more educated about the industry. So thank you for your time, and I'll give you guys all back a few minutes by ending early. Thank you.